Hi, pre-calculus students. Welcome to section 11.1, the 3D coordinate system. I hate to state the obvious, but it's because the world is 3D. Here is a picture of the X, Y, Z 3D axes on a 2D board. So that's kind of hard to show it that way, but we do the best we can with it. And I have provided you with 3D graph paper on 2D paper. So when we are in class together, I will pull down my 3D axes that are really 3D, and we'll talk about this some more. But the way the 3D axes work is what you are used to is the XY axis on a plane where your X is going left and right and your Y is going up and down, showing the height. So essentially what's happening here is we are pushing the XY axes down so that it is a horizontal plane coming toward you and away from you, right? And so now the x-axis going away from you is negative and the x-axis coming towards you is positive. To the right are your positive y's and to your left are your negative y's. This allows for one more dimension, right? A z-axis that goes through that plane at an origin 0, 0, 0, where positive z's are going upward and negative z's are going downward. So what happens then is that there are now 4 octants where instead of, there are 8 octants, obviously octant meaning 8. When you have an XY plane, of course, there's 4 quadrants, right? So when you have a 3D axes, X, Y, and Z, there are 8 octants. There are 4 on top of the XY plane, and there are 4 below the XY plane. The first octant is where X, Y, and Z are all positive, okay? In other words, it's on top of the XY plane to the right in front of you. And then the way we count the octants is we go counterclockwise, just like we do on an XY plane, away from us and around, coming back towards us. So the first octant is 1, 2, 3, and 4. Then we drop below the first octant and count 5, 6, 7, and 8. Okay, so what we're going to do is we are going to graph the points that you see below here. And we really could just graph the points, but so what happens is when you're trying to graph 3D points on a 2D plane, if you just graph the point and hang it out there, it is very hard for another person to read that point from that location, right? And so what we do is we include some depth. We make that point a vertex of a rectangular box so that we can see its location, okay? So let's give this a try. Let's first graph the point 0, -3, 0, just because that's a little easier to see. And then we'll graph with some 3D help, using a rectangular box and help the other 2 points. So the point 0, -3, 0, of course, this point here is 0, 0, 0. Our first 0 indicates that we will not come out towards us or away from us. So we are still at the point 0 here. The -3 indicates that we will go -3 on the y-axis to the left. So we are located right here now. And 0 z's indicates we will not go up or down. So this point that you see here is our final destination, and it is located on the XY plane, 3 to the left. Okay, let's graph the point -3, 1, and 2. So I think I might need my black marker. Here we go. Okay, so to graph the point -3, 1, and 2, we're going to kind of mark our location along the way with X's, and our final point, we will make, a big dot so that we can see that. So we are first going to go -3 on the X-axis. So we are going to go start at 0, 0, 0 and go behind us 1, 2, 3. Right, so I'm going to put a little X here. So what it looks like right now, though, is it almost looks like we moved up and to the right, right? And we did not. It's just us trying to show depth on a 2D plane for our XYZ 3D system, okay? So the next thing I have to do is move 1 to the right from where I was. I'm going to move 1 to the right. So notice then, this is a length of 1. I'm not going to move 1 to the right on the y-axis. I'm at this location right now. So I am going to move 1 to the right. And now I am located at this point. So let's kind of show where we are right now. Right? So here's where we are. I could have drawn my a little bit more parallel, but we are on the XY plane, right? We have not moved up or down. And and here's the plane right here, and we are at this location. The last thing we're going to do is move up 2, right? So I'm going to move up 2. So notice that here is a z-axis. I'm not going to move right on it because here's my location, but I'm going to move up 2. And here is my final point. Now, let's add some depth to this, okay? So what's happening here is the bottom part of my rectangular box, right? And to show the depth for each of these points, I am going to move up 3. There we go. There we go. So now that's a little better. We can see our point here. We can see that we moved -3 on the x-axis, 1 on the y-axis, and up 3. And we can kind of see the depth of where this point is actually located. Notice that -3, 1, and 2, right? -3 right here. And then on the x-axis, and 1 on the y-axis, and 2, oh, that was supposed to be 2 on the z-axis. Did I move up? Oh, I moved up 3 in the front. Sorry about that. There we go. There we go. Sorry about that, little better. There we go. So let's talk about that again. We moved -3 on the x-axis, 1 on the right, and up 2 on the z-axis. So what I did then is I filled in my XY plane, and then I went 2 up from each point on the XY plane, right? And then made the connection to form a rectangular box. Now I can see that this point is located at -3, right? Right 1, so 1 for y, and up 2, right? And I can kind of see the depth of where it is. And what I just wanted to tell you is notice if you go -3 on the x-axis, that point is on the box. If you go 1 on the y-axis, that point is on the box. If you go 2 on the z-axis, that point is also on the box, and it helps you form it. Okay, let's erase, and I'm going to graph the point 2, 3, -2. right, in purple, let's graph the point at the bottom 2. So we'll go 2 forward on the x-axis. I'll put an X, that's where I'm located right now. 3, so I'm going to go 3 to the right from the location where I am. Here is my location now. I will show that I am still on the XY plane. I have not moved up or down yet. I'm located here, and now I'll go -2 down from where I'm located. There we go. Here is my final point here. I will go -2 from each point on the box to show the depth. There we go. And now if a person came to see where this point is actually located, they can see that you went 2 forward, 3 to the right, and 2 down, right? Again, notice that 2 on the x-axis, that point is there. 3 on the y-axis, that point is there. -2 on the z-axis, those points are all there to help you draw that box. Okay, we have some formulas that you're used to. The distance and the midpoint formula are the same, except we have one more component added. So you have squaring your, subtracting your x's squared, subtracting your y squared, subtracting your z squared, and you're adding them up. The midpoint is the same, adding your x's, adding your y's, divide by 2. It's just that now you do that with your z's. Rather than have the equation of a circle, like here, we have the equation of a sphere. So we have our perfect square binomials on our x's, our y's, and our z's, and that equals our r squared. So let's answer some questions here. Let's find the octants where x is less than 0, y is greater than 0, and z is less than 0. There is one octant where that happens. Again, so let's see if we can picture that. Okay. First of all, where our x's are less than 0, right? Those are the octants behind, right? So that would be octant 2 and 3, right? So let's get a little list. That would be octants 2 and 3, and below would be 6 and 7. Okay, so these are the octants that we're working with now, right? So here we go. Right, we're counting, there's octant 1, 2, and 3 are behind, 4, 5, 6, and 7 are behind, right? And where are the y's greater than 0? Those are the octants on the right. So that would be octant 2, right, is on the right, 3 is not. 4, right, 4, and then octant 6 is on the right, 7 is not. So now we're talking about octants 2 and 6, right? And we want the octant where 6 is less than 0. That is octants below the XY plane. 2 is above, so it's not 2. Octant 6 is below, and our final octant is 6. Let's write the equation of the sphere with the diameter at the endpoints of 1, 0, 0 and 0, 5, 0. So notice the center point of the sphere is located at H, K, and J is the center of the sphere. So that point is the midpoint of the endpoints of the diameter. So let's use the midpoint formula here to get the center of the circle. 1 plus 0 divided by 2 is 1/2. 0 plus 5 divided by 2 is 5/2. 0 plus 0 divided by 2 is 0. Now what we need is the radius, and we'll have everything we need. There's 2 ways to go. I could use the distance formula between these 2 points, right? The center point and a point on the diameter, or these 2 points. But I think what I'll do is find the length of the diameter and divide that by 2, right? So let's use the distance formula. Here we go. Let's subtract our x's. That's 1 and square. For our y's, let's subtract our y's. And so that would be -5 squared is 25. Plus, for our zeros, right, 0 minus 0 is 0 squared is 0. So we have the square root of 26 is the length of the diameter, so the radius must be half of that. Let's put that in the sphere formula. So that would be x minus our h is 1/2 plus y minus our k is 5/2 plus our z minus 0, so we'll just have a z squared. And then our radius squared goes here. So our radius squared is the square root of 26 over 2 squared. Notice we will have, when we square, we'll have 26 over 4 or 13/2. So here is the equation for our sphere here, and it's equal to this radius squared. Now, I wrote it too small, no worries, over here, because I'm going to erase. They gave us the general form of the equation of a sphere, and we are going to find the center and the radius. So I'm going to pause and erase here, right? And write that equation bigger. Okay, so this was the equation of the sphere we've been given. I did keep the generic equation of a sphere here. They are asking us for the center, which is h, k, and j, and the radius. All right, so if you notice, we have 3 perfect square binomials. So let's work on that, and a constant on the right. So let's first gather our x's, then our y's, then our z's. So we have 4x squared minus 4x plus 4y squared minus 32y plus 4z squared plus 8z. And I am going to subtract a 33 from both sides. Okay, now what I'm going to do is I need to do some completing the square. Notice that each of these variables, x, y, and z, have a coefficient of 1. So for each one of the variables, I am going to factor the leading coefficient. So from the x's, I am going to factor a 4. That will leave me with x squared minus x. I'm going to put plus blank because I know I'm going to be making a perfect square trinomial there. Okay, for my y's, I'm going to factor a 4 from my y's, right? That would leave 1 here, minus 8 here, plus I'm going to leave a blank to make a perfect square trinomial. I will do the same for my z's. That will leave a z squared plus 2z equals negative 33. All right, let's take a look here. Half of b squared. Half of negative 1 is negative 1/2. Squared is a 1/4. Again, so I'm adding a 1/4 in parentheses here. Half of negative 1, negative 1/2 squared is 1/4. Notice on the left-hand side of the equation, though, this is really a 4 times 1/4, which is 1. I've added a 1 to the left-hand side of the equation, I'm going to add a 1 here. For the y's, half of -8, -4 is -4 squared is 16. 4 times 16, I've really added a 64. For the z's, half of 2 is 1, squared is 1, I've added a 4. Okay, so I'm going to go below here now, and I have 4, and I'm going to write my perfect square binomial for the x's. That would be x minus 1/2. If you remember, it's half of b, it's what you squared. Plus for my y's, that would be y minus 4 squared. For my z's, that would be z plus 1 squared. Equals, and let's see, I have 64. Let's see, I have, what do I have over here? 69 minus 33. Oh, that comes out real nice. That's a 36. Okay, well, if you notice, each one of these perfect square binomials does not have a coefficient out front. So I am going to divide everything by 4. There we go. And we have x minus 1/2 squared plus y minus 4 squared plus z plus 1 squared equals 9. So my center point is 1/2, 4, and -1, and my radius is 3. There we go. There you go. Now, I also decided when I wasn't recording the video that I didn't like my first attempt at graphing a point, but I had already talked so long, I didn't want to redo the video. So if you've got graphing points, good for you. If you need to see one more example, I cleared my 3D axes here, and I'm going to graph the point 1, -4, and 3. So let's go ahead and do that if you want to stick with me. So 1 would come forward on the x-axis. I am here right now. -4, I will go -4, so that will be to the left on the y-axis from where I am. So 1, 2, 3, 4, I am located here, right? Here is, I have not moved up or down, so I am currently on this XY plane, right here. Excellent. Now, I'm located here, I will move up 3, that would be 1, 2, and 3, and here is my final location. To help show that, I will move up 3 from every point I have on the XY plane. Here we go. You can see that depth a little bit better. There we go. So you can see our final location here. We are 1 towards us on the x-axis, left -4 on the y-axis, and up 3 on the z-axis. Again, notice that the point 1 towards you on the x-axis is here, left -4 is here, and up 3 is here to help you with your graphing. So I hope that helped. Have a great day.